Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I am your instructor, Jim Herby. In this episode, we're going to continue in Module 6 of the objectives and discuss Section 6.4. Our topic is Encryption Use Cases. Let's begin. Plain text is your original readable form of your data before beginning the encryption process. The encryption process involves taking our plain text data, sending it through an algorithm to come up with a final data state that is encoded called ciphertext. Plain text can be an original typed document, an image file, a movie recording. Plain text is just the state that your data is before it goes through encryption. If we send data in plain text form across our network, it is vulnerable to unauthorized access by third parties. So we use encryption to maintain confidentiality of our data and the integrity of the plain text to ensure that our data is the same as it is at destination as source. Ciphertext is the encrypted version of data. We take our plain text data, the file, send it through an encryption algorithm, and come out with an encoded version of our data. Most encryption algorithms have a set key length. It could be 128, 256. The number refers to the amount of characters within the encrypted output. Your encrypted output will not be all of the data that was within your document or the image file. It will be an encrypted string of characters. And the user at destination, that is receiving the data across the network, will need the appropriate encryption key to decrypt the data. When plain text goes into an encryption algorithm and comes out in a ciphertext version, we have an encryption key that is tied to that process. We also use a decryption key that can be used to convert ciphertext back to plain text. We can use one individual key for encryption and decryption, or we can have separate keys depending on the type of algorithm we are using. We use encryption for our stored data. We call that data at rest. All of our solid state drives, hard disk drives, USB flash drives, all of our different storage media, we want the data that is stored on those to be encrypted, data at rest. Data at rest will prevent our data that is stored on the device from being accessed by unauthorized people if the storage drive is stolen or compromised. Data at rest encryption can come in both file level and disk level encryption. And data at rest must have backup copies of our data. We need to ensure we have full encrypted backup copies so that we can restore our data if we have some type of failure or breach. There are two levels of encryption within data at rest: file level and disk level. File level encryption will secure encryption on individual files or folders within the storage drive. And to unlock the data that is contained within an encrypted file, the user must have the appropriate encryption key to access the information. Within Windows, we use EFS, the encrypting file system, to allow for file level encryption. We also can be selective with our encrypted files. We don't need to encrypt every file, but we can use file level encryption if we want to identify particularly sensitive data contained within an individual file. We also have disk level encryption. Disk level encryption secures the entire storage device. All of the files that are contained within the SSD, the hard disk drive, will be encrypted. Within Windows, we use BitLocker. BitLocker is the tool that provides disk level encryption for our data. Within Apple's Mac OS, we use FileVault. Disk level encryption will ensure that all of our data that is stored on the device will be protected if the device is lost or stolen. Data at rest encryption will also include our mobile devices. We want all of our sensitive and critical data stored on our tablets and smartphones to be encrypted. Your mobile devices will have encryption utilities built directly into the operating system. They are integrated with your device and screen locks to provide a robust system for protecting against unauthorized people. If your mobile device is lost or stolen, both your encryption and your screen locks will act together to protect your data. Our second type of encryption is data in transit. Data in transit is ensuring that all data that is being sent over a network connection is encrypted. The two most common ways we use for data in transit are SSL, Secure Socket Layer, and TLS, Transport Layer Security. With our web traffic, we can add encryption through HTTPS, the Hypertext Transfer Protocol Secure, which encrypts all of our web traffic, and VPN tunnels. VPN is Virtual Private Network, which allows remote users to create secure connections with our internal resources. Data in transit is applicable to our emails. We want to ensure all email messages are encrypted from source to destination, all of our instant and text messaging, as well as all of our cloud services. Remember, to access the cloud, we need an internet connection. All of our data and transmissions going over that connection need to be encrypted. With data in transit, we encrypt all of our emails. We want to ensure that all of the attachments, the files that are contained within a message, as well as the message itself, are encrypted. We can use methods like PGP, the Pretty Good Privacy, or SMIME, as ways that we can provide this encryption within email. The end user must have a decryption key to access the data within the email. Most of your modern email systems will have the decryption key included within the transmission, so that when the recipient at the other end can verify they are the correct recipient, they can open the contents of the message. HTTPS, Hypertext Transfer Protocol Secure, encrypts all of our web traffic between our browsers and our web servers. With older technology, we use SSL, Secure Socket Layer. With modern connections, we use TLS, Transport Layer Security. HTTPS helps to prevent on-path attacks, where unauthorized people will sit in between source and destination of our web traffic and attempt to extract data from the connection. We can identify that HTTPS is enabled in two ways. When looking at our web browser, look at the top right corner for a padlock icon. If the padlock icon appears, you're using HTTPS. Within your browser address bar, you will also see your URLs beginning with HTTPS://. If that appears, you know you are using the secure version of HTTPS. It's very essential to use encrypted web traffic for all of our session logins, data submissions, and any financial transactions that we do online. VPN is Virtual Private Network. VPN is a technology that allows us to encrypt all of the traffic between a remote user's device and a VPN server. The most common configuration is having VPN software that is downloaded onto the remote user's host device. Within that software interface, the remote user can authenticate themselves and create a connection to our internal network. Once the remote user has been identified and verified, we can then establish a tunnel between the remote user and internal servers for connectivity. And the VPN will be able to mask all of the remote user's IP addresses and web traffic. VPNs are also effective when we are on untrusted networks like a public Wi-Fi. We can use a VPN connection to provide us our encryption and security. Lastly, we will discuss mobile application encryption. Your mobile apps are the common way that our smartphones can interact with different services over an internet connection. We want all of the data that is being transmitted and stored within our mobile apps to be encrypted. We use end-to-end encryption. This ensures that not only is mobile app data encrypted in data at rest on the mobile device, but that all communication channels being used by the smartphone will also be encrypted, and that the recipient at the final end of the connection will have encryption and the appropriate decryption keys as well. That will conclude our discussion of Section 6.4 Encryption Use Cases. In our next episode, we will move on to Section 6.5 in the objectives, which will be our last lecture, and our topic will be wireless security. We thank you again for following along in all the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.